All right. Notes 3 for this unit, more power rule problems. So there's no new rules today. It is the same. We want the derivative of x to the n. We move the power down front, and we decrease the power by 1. And then, again, how we make that tricky is things like this first example with weird roots and powers and things in the bottom because that's negative. And so, there's really not a way to complicate this other than to make the numbers fractions and negatives. So let's see what other tricks we can pull with this rule. Find the slope of the line tangent to the curve. Okay, well, again, that's the same thing as find a derivative. So we're going to learn all these different ways to ask for a derivative. And slope of the tangent line is one of them. One of the ways we ask for it. I am not going to take a derivative first because I don't take derivatives of roots or things in the bottom. So I'm going to change this. I'm going to do some algebra on that thing. And find my third period popsicle sticks. So, Victoria, how would you rewrite the fourth root of x cubed as a power? The flower power grows on the top and the root grows on the bottom? 3/4. So x to the 3/4 plus 6. Jace, I got x to the 5th in the bottom, so how do I write that as x to the negative 5 minus 14. Ethan, how about this last one? How do I rewrite the 7th root of x squared in the bottom? How do I rewrite that as x to some power? Okay, this is algebra stuff though. Powers and roots. I know, it's been a while. I'll come back to you. Macy, bail us out here. How do I rewrite, or how do I write the 7th root of x squared in the bottom? How do I write that as a power? Negative 2/7. Okay, so all of that was Algebra 1 stuff. Now we can do our calculus stuff. And you know what? We can just find all kinds of people to help us with this one. There we go. Because we just go piece by piece here. So, Sophia, what's the derivative of 2x to the 11th?
It would probably be 2 times x plus h to the power of 11.
Wait, that's like the long way around the derivative. I just want the shortcut. How do I use the shortcut to come up with the derivative of 2x to the 11th? Yes. Do you know where that comes from, other than Emma?
I know you subtract the power by 1.
So, yes, that's sort of the second step. The first step is take that exponent, multiply it to the front, and then decrease the power by 1. So, Naomi, how about... Oh, you got fractions to deal with.
Negative 9x to the negative 1/4.
Very nice. So 3/4 times 12 is 9, and then 3/4 minus 1 is negative 1/4. So Naomi got lots of fraction work in there. Leah, how about the derivative of 6x to the negative 5?
Wait, why is it negative 1/4? Because you subtract 1.
It's negative 1/4 because I...
Okay, I got it.
Leah?
30x to the negative 6.
Good. Again, that's one where people miss because they think 1 less than negative 5 is negative 4, but that's not right. Gabby, you got some fraction work here.
I was like going for half. I don't know how to do it.
So, keep calling on people who were absent. So 2/7 times 14, that would be 4 plus 4 And then I'll decrease negative 2/7 by 1. So McKenna, what's negative 2/7 minus 1? Negative 9/7. All right, that was exactly the same stuff as we did yesterday, and again with all of the mixed up pieces in there to try to confuse people with negatives and with fractions and with negative fractions. Number 2, consider the function given by this thing. What is the slope of the line tangent to the graph when x is 1/3? So we've added a little bit to this problem. When x is 1/3. We'll worry about that at the end. But slope of the tangent line means take a derivative. But before I take a derivative, I should get it to where I can take a derivative, because I can't take a derivative of the top and derivative of the bottom and then like put them back together. It doesn't work that way. It would be really nice if it worked that way. Jeshen, how about help me out with some algebra here? What do I get if I divide each of those by x?
So 6x squared for the first one, negative, and then 3x divided by 1.
Good. So then it's time, now I can take a derivative, which means I can call on more people. So Jameson, how about the derivative of that first term? 12x. Dylan, the derivative of the second term? I mean, it's easy, but it's tricky easy.
0.
Yes. Did you know that other than someone whispering it to you? There's
no. Yeah.
Well, there's two ways to think about it. If I look at just the 8, and I think about y equals 8, horizontal line, slope is 0. The other way to think of it is as 8x to the 0, right? Because x to the 0 is 1. Like you would never write that, but that's what it means. So you multiply by 0, and it wipes out the term, and you're done. After you've done these a few times, you start to realize, I don't need either of those tricks. I just know the derivative of a constant is 0. Zach, how about the last one? Very nice. Okay, but we're not done with this, because it says, what is the slope when x is 1/3? So let's plug in 1/3. So the slope at 1/3 means f prime, plug in 1/3. So 12 times 1/3 minus 3 times 1/3 to the negative 2. So 12 times 1/3 is 4, that's easy. Minus, flip the 1/3 and square it. So if I flip it, I get 3. Square it, I get 9. Multiply by 3, I get 27. Hope that wasn't too many algebra steps without showing steps. So negative 23. So that means the slope at 1/3 is negative 23. So we found the sort of the slope anywhere first, and then we plugged in 1/3 to find the slope at 1/3. Number 3, find the values of x. McKenna?
Okay.
Yes.
The notes on mine, it says answer the value of 14. I have no idea how to
For number 2?
do it. Yeah.
The key I'm looking at says negative 23, so I don't know. Those notes are wrong. I want something changed or something, but no, it should be negative 23. Addie's looking for the mistake. Number 3, find the value of x at which that thing has a horizontal tangent line. Okay, horizontal tangent line, I know what that means. That means take a derivative. What's horizontal mean? Okay, yes. That's a good start. Slope is equal to 0. So that means I need to take a derivative And it's kind of the opposite of the last problem. The last problem we plugged in 1/3. For this problem, we want to know where it equals 0. So for this one, the answer is going to be 0. We need to figure out where that happens. But I need to take a derivative first, although I can't really take a derivative yet until I clean that up with some algebra work that Andrew is going to help us with.
5.
Yep. Yeah, do it all. You got it.
I have no idea what happened to everybody.
All right, we'll bail you out. Cade, how about the next term?
Negative 4x.
Since we're going term by term here. Mariana, how about the last term? Dividing, not derivative yet.
-2 to the x to the -2.
Good. Again, that's only algebra, that's not derivative, but that gets me to where I can now use the power rule, and I can ask 3 people to help me with the power rule. I'm searching for Dylan's popsicle stick for that first one, but Kaylee, that's a different class altogether. Cadence, McKenna, Caden. So, Cadence, how about the derivative of 5? 0. McKenna, the derivative of -4x to the -1?
4x to the -2.
Yes. And Caden, next one?
4x to the -3.
Plus 4x to the -3. Okay, so yes, good. We found our derivative. What do we want to do with that derivative?
Find out what equals to 0.
Yeah, set it equal to 0. Don't plug in 0, but set it equal to 0. So 4 over x squared plus 4 over x cubed equals 0. Oh, that's kind of yucky algebra. Thoughts on what we should do algebra-wise for that? So common denominator is one answer. What was the other? Somebody say something else? Not cube it, but you could multiply through by x cubed, and that would sort of wipe out the denominators. But those are similar answers. We'll go common denominator first. So 4x plus 4 over x cubed equals 0. So the only thing that makes a fraction 0 is if the top is 0. So this looked like a terrible problem, but it turned into x equals -1. What did I...
Oh, you wrote in the x.
So I multiplied top and bottom by x. And so there's my 4x plus 4 over my common denominator of x cubed. And then, well, you could phrase it this way. You could multiply both sides by x cubed, and that would go away. I just said the only way to make a fraction equal to 0 is if the top is equal to 0. So I just grabbed the top and set it equal to 0. So kind of a weird problem, I think, because we have time. I'm going to graph that thing and see if indeed there is a horizontal tangent line at -1. So 5x squared minus 4x minus 2 all over x squared. Let's just see what this thing looks like. Well, at -1, that doesn't look like the right answer. Did I type this in right? 5x squared minus 4x minus 2 over x squared. Maybe I'm just not seeing it all. Oh, it is a horizontal tangent line at x equals -1. Like right around there, it sort of makes the turn from increasing to decreasing. So there's a horizontal tangent line there. A little trick. Second calc, dy dx. at negative 1. Okay, well the calculator does things numerically, but negative 4e to the negative 6, that's pretty close to 0. Yeah. So I feel good that there is a horizontal tangent line at x equals negative 1. That is a weird looking graph. Number 4. Consider the curve given by, at what value of x is the slope of the line tangent to the curve equal to 2? So how are we going to do this one? Kind of the same thing, except set it equal to 2. So why don't you try this one? Take a derivative, set it equal to 2. And it's already set up to be at least kind of nice. It's ready for the power rule. So we take a derivative, set it equal to 2. If I subtract the 2, that goes away. And now I've got 4x cubed over 3 minus 9x to the 5th equals 0. So that's still not great, but it's way better than what it was. So what do you want to do to solve that? I see two things that we could do. That's what I would do first. 4x cubed minus 27x to the 5th equals 0. That way we don't have any more fractions to worry about. Next what would you do next? Well, don't divide by it because then you'll lose it, but I would take out the x cubed. 4 minus 27 x squared. And now I can set each of the pieces equal to 0. So x cubed equals 0, that's easy, x equals 0. So I'm getting more than one answer here. And then 4 minus 27x squared equals 0. That one's going to be kind of yuck, but... So x squared is 4/27 square root. I can't square root 9, or square root 27, at least, and get a nice number. 2 over square root 27. So there's my 3 places where the slope is equal to 2.
Wait, you have to.
And I think because we're doing calculus now, we're going to make the swap and say we don't have to fix square roots in the bottom. We do all sorts of things in calculus. We leave answers that you would never leave anywhere else. We'll call them safe stops. And the idea is, hey, if you're doing calculus, then don't bother me with your trivial little algebra 1 stuff. Leave it alone. Let somebody else do it if they want it. Number 5. Write an equation of the tangent line. Uh-oh, that's new. All right, the equation of a tangent line to this graph when x equals 3. Well, anytime I want to write an equation of a line, just forget the tangent line, just any line at all, it would be nice if I had... Actually, you tell me, what are the different forms of the line? It goes way back to 8th grade algebra here. You remember the formats of the line? Point slope form, that was one form. Y equals mx plus b. There was also a standard form that nobody liked because, why would you do ax plus by equals c? So our choice is always going to be point slope. So if I can get a point and get a slope, then I can write the point slope form of a line. Do we need to remember or rehash what the point slope form of a line is? Probably.
Y minus y1 parentheses x plus x minus.
Some of you remembered it. Y minus y1 equals m times x minus x1. We like that form because we don't have to do anything to it. We can leave it like that. We don't have to change it into standard form or move things around. We can leave that as our answer. Okay, so I need a point and a slope. They gave me x, so there's my first step. How could I find my y value?
Plug it in.
Plug it in. So g of 3. Let's see, 9 times 2 is 18. Minus 12 plus 5, that would be 6 plus 5 is 11. Alright, so I got my point. My point is 311. Now I need a slope. How do I find the slope? Slope at a point, right? Not an algebra slope, but like a calculus slope. Slope at that point. I need to find the derivative and plug in 3. So derivative equals slope, slope equals derivative. Like that's the basis of first semester of Calc AB. Slope equals derivative, derivative equals slope. You make that connection and you're halfway there would be a bit of an exaggeration, but you're well on your way. So derivative, let's see, that would be 4x minus 4. And then to find the derivative at 3, plug in 3. 4 times 3 minus 4. 12 minus 4 is 8. So this took some work to find the point. Took a little more work to find the slope. But now I'm ready to use my point slope format. Y minus 11 equals 8 times x minus 3. And because we like that form of a line, we don't have to distribute, move things around. Like just leave it in point slope form and we're good. Let's skip number 6 in the interest of time. It's the same thing as number 5. See number 5. I mean, the derivative is a little harder because we got to do some, change that up a little bit, but it's the same setup as number 5. Number 7, new word here, relative extremum. Fancy words. Relative extremum. Okay, well, relative extrema. So, like, this doesn't mean, like, you have a crazy aunt or uncle. Like, that would be an extreme relative. That's not what we're talking about here. We're talking about a extremum, so like a max or a min. Maybe not the overall max or a min, but, like, relative to the people around it. X cubed looks like this. So my relative extrema, there'd be a relative max and a relative min. So I'm kind of expecting one of each. I think I sort of said this earlier when we looked at the calculator. What's the slope of the tangent line at a relative extrema? So a relative extrema has a slope of 0. Or maybe we should better phrase that, a dy dx of 0. And so now it's like all the other problems or some of the other problems we did. Like we put the different words on it, but it's find a derivative, set the derivative equal to 0, and figure out where that happens. So y prime would be 12x squared plus 4x. And we want to know where that is 0. Factor out of 4x. Set each factor to 0. Don't forget about the factor out front. So x equals 0 and x equals negative 1/3. And we're not quite to the point. Like in calculus, we'll do some like proofs why those are max and mins. We'll say which one is which. But right now we're just going with the idea of an extrema happens when the slope is 0. So find the slope, set it equal to 0, and That's enough for now, basically. All right, number 8. These don't require any work, they just require some thought. What values of x satisfy f prime greater than 0? Remember, f prime is the slope, or the instantaneous slope. So if my slope is, no, not greater than 0, equal to 0. So where is the slope equal to 0? At the extrema, yep. So give me some points.
1.2.
And it says what values of x. So 1.2 would be one of them.
3.3.
1.2, 3.3, and 0. Right, because those have a slope of 0. On what intervals is the, again, when I see derivative, my brain needs to think slope. So on what value is the slope negative? Well, if the slope is negative, well, slope is negative though, so I want my function to be decreasing. So that's a fancy way to say, where is my function decreasing? So read a graph like you read a book, left to right. Negative infinity to 0. And then 1.2 to 3.3. And that's our decreasing part of the graph. Decreasing. So all the same logic here. If f prime is greater than 0, what are we looking for?
Increasing.
Where f is increasing, because that would mean the slope is positive. If the slope is positive, we're going up. So I want f to be increasing. So that would be from 0 to 1.2 and 3.3 to infinity. Okay, 11, we try to get tricky on you here. On which of the following intervals is f greater than 0 and f prime less than 0? Again, I'm going to translate that because f prime less than 0 means f is decreasing. So I want my function to be above the x-axis. I'm trying to translate this into the picture so I know what to look for. So I want to be above the x-axis but going down. So where am I above the x-axis and going down? 1.2 to 2. Yes. Yeah, but also over there, negative infinity to 0. So just trying to force you to think about two things at once. Second one, f prime less than 0. So what does that mean on the graph? What am I looking for? F prime less, no, excuse me, f is less than 0. So what does that mean? Y is less than 0, or I'm below the x-axis. But I also need to be increasing. So yeah, what did you say, Andrew? 3.3 to 4.
Is it 1.2 because like when we're doing the x value?
Back here? So 1.2 to 2, because I need to be above, so I can't even look at this stuff over here.
Like, why wouldn't it be z? Like, it's not 0 because you're not doing the x. You're saying it's on the.
I'm given x values.
You're only just doing x values.
Correct.
Okay.
Because intervals is x values.
Okay. It's not points.
Not points. Yeah, that's right. That's not a point. That's an interval. Which, that's a good question, because if you just looked at that on its own, you wouldn't know if it's a point or an interval. But in the context of the problem, it's an interval. Okay, today's assignment, worksheet 3. Again, so nothing new today, like my 3 there. Tomorrow I won't see you. Yeah. You excited not to see me? Is that what that was?